Now let's talk about using the calculator when defining probabilities here. Now to graph a normal distribution, we can use the normalpdf option on our calculator. Now this option can be found in the distribution menu. Go to second bars, which is the distribution menu, and now select option 1, normalpdf. Let's consider the following normal distribution. Suppose our random variable x is normally distributed with a mean of 10 and a standard deviation of 5. Now, let's go ahead and graph this distribution on our calculator. Okay, so my calculator's been loaded here. Notice if I go into second distribution, the normalpdf option is the first option right here. Now I'm not going to call it up yet. I'm going to go into y equals. I'm going to go ahead and type this in again. I'm going to do second distribution. I'm going to do normalpdf. I'm going to let my random variable be x here. The mean of my distribution is 10 and the standard deviation is 5. Now let's go ahead and graph this. And notice our nice bell-shaped curve here. This has a normal distribution with a mean of 10 and a standard deviation of 5. Now, it's important to set an appropriate window here, and I went ahead and just let my window go from -5 to 25. I went with a scale of 5. And then I let my probability values only go from 0 to 0.1. So I can kind of see the nice bell-shaped curve here. Give me a nice distinctive feature here. My graph didn't get that high because of the constraints of the normal distribution, but once again, if I look at that graph, that gives me a nice bell-shaped curve. Now, recall that under this option 1, this option normalpdf, and there really is no such thing as calculating the probability that x is equal to an exact value like we did in our discrete case. Of course, that probability would be 0. This option is solely used for graphing only. So once again, do not use this for calculating probabilities. Only use this as an aid or a tool in graphing a normal distribution. Now let's talk about the features on our calculator that calculate areas underneath the normal curve. To calculate the area under a normal curve, we could use the NormalCDF option. And that's the option you're going to choose to calculate probabilities, because recall, all probabilities for continuous distribution represent areas underneath a curve that cover a range of values. So we're going to accumulate using the NormalCDF function, which stands for cumulative distribution function. Now this option can be found in the distribution menu as well. Go to second bars, which is the distribution menu, and now select option 2, NormalCDF. Now let's consider again the following normal distribution. Suppose x has a normal distribution with a mean of 10 and a standard deviation of 5. Now I want to find the probability that x is between 0 and 8. Notice that once again I have this graphed, and you know it's like finding the area underneath the curve, which most of you who are in calculus know that's found by integrating the function between those boundary values, and we probably could do that with option 7, letting our lower limit here be 0, and in our upper limit, let's go ahead and let our upper limit be 8. And if I press enter, it's going to give me the probability associated with that of 0.321. Now, we don't have to do it like that every time. We don't have to graph and then find the area by using an integral function, but we can go just to our home screen here and calculate that area by doing second distribution in NormalCDF. Now those of you that have updated your software, your calculators may come with a full menu that incorporates those. If not, we're always going to put in 4 parameters here when calculating the area underneath the normal curve. We're going to put the lower bound, which is 0, followed by the upper bound, which is 8, in our probability statement. And then this applies to a normal distribution that has a mean of 10 and a standard deviation of 5. So once again, the NormalCDF function requires 4 parameters for entry: lower bound, comma upper bound, comma mu, comma sigma. And when we press enter, it's going to give us that respective probability. The probability that x is between 0 and 8 for a normal distribution that has a mean of 10 and a standard deviation of 5 is 0.322. Now,